Hi, I'm Ralph, and this is Lucas. Lucas is a technical director. I'm a team lead at Unity. And maybe that's not that interesting, but you can follow us on Twitter, where we tweet a lot about the things we we're working on. Sometimes we have big questions for people, and we try using Twitter as a way of polling. So please use that as a channel to us. But enough about us. Oh, actually, I forgot one thing. We're both Dutch, so this is a home game for us. Hallo.
Zeker weten!
And we're going to be talking about IL2CPP today. Now, the topic here, compiling your code now in the future, is kind of the mix of all the things that we want to talk about. To give you an idea of the agenda, what we want to talk about is first, IL2CPP, what is it? Then slightly tangent scripting and what it is within Unity and how IL2CPP fits in with that. Then what IL2CPP does today. Then what IL2CPP will be doing in the future. And what we would like to do together after that, because this is kind of a very broad topic, is do a little bit of a longer Q&A. We're a small group, we're not that many people, so there's a couple of people who will be running around with mics. And we'd be very happy to kind of cue that as...
Don't be shy.
Yeah, please don't be shy. Now, there's a thing I wanted to share, and there's always something that you want to share new during a presentation. One of the things that we wanted to share today was a little bit the history of this name. This was not really the name that we wanted to use for this thing at all, but it's kind of like the technical term that describes it best. To give you an idea what the other names were, the first one was really, really lame. It was called Hawk before we called it anything else.
I never heard that.
Yeah, the original branch name was Hawk. Then there was a version called IL2CPP, which was a slightly different approach than this. And then when we had to actually find the name, because we were bringing it out on the world, we tried to call it Stereo for a while. We instead of Mono. No, nobody. Then there was Mongoose, and in the end, this is now the real name. It's the project name. It's kind of boring, but it's very
Marketing team fucking hates us for it.
Yeah, they really
They give me crap about it every time.
IL2CPP. So it's a bit of a, yeah, what would I say? Interesting descriptive name. Intermediate language to C++. Very descriptive. It's a cross-compiler from Microsoft Intermediate Language to C++. Now, to understand why we're working on this and how it fits into Unity and why is it so important to us, you need to kind of understand, well, how scripting in Unity works. And who better than Lucas to kind of talk about that?
All right, so scripting in Unity. If you look at the Unity code base and all our different subsystems, pretty much all of them are written in C++. Like our physics engine, the lower parts of a networking engine, rendering, calling, procedural, textures, audio. C++, it's everywhere C++. Now, sometimes you see Unity being described as a C# game engine, and it just, I'll go, it's not true, because it's all C++. More than 95% is C++. So you can wonder, if all of that engine is C++, then why did we choose to let you guys write in a different language? Because your code, we let our customers write code in C# or in Unity script. And then, you end up with this kind of weird situation where you have two different programming languages that kind of work, reasonably different, and you have them in the same program. Does that really make sense? And I think it does. I think it does. So the reason why we use C++ for pretty much all our subsystems is that it's really fast, and it's just what we know. To be honest, like it's what we learn in school. But we're not actually really big fans of it. In fact, I would say that most of the people that work on C++ code in Unity, we actually hate it. And there's a lot of things about C# that we like a lot better. And the first thing is that in C#, it's much harder to do something wrong. It's much, much harder to do something wrong. For instance, one of the things that C# gives you is like memory safety. Like if you have an array that's has a size 100 and you try to write it index 200, if you do that in C#, you get an exception. It says oink, I don't know, like array out of bounds something exception, and you immediately realize what the problem is.
Index out of range exception.
Thank you, index out of range exception. If you do that in C++, you just write in some random memory, nothing goes wrong, and then 10 minutes later, a completely unrelated subsystem crashes, goes wrong. So, I'm not lying if I'd say that, due to these safety problems, or like problems in C++, the engineers at Unity, we spent a frustrating amount of time chasing these problems. Another thing that we like about C# is that even though it provides the safety, it's still reasonably fast. And this talk today is about IL2CPP, which is actually a project that makes it even faster. Especially when you compare it to alternative scripting languages, like Lua or something homebrew that you could throw in. A third thing that we really like about C# is the base class library. So, the C# base class library, or BCL, it comes with, array, list, hash table, like your container stuff. But it also has, crypto and file IO and what else? Like reasonable string handling, like all these things that you kind of take for granted. Sockets, and all these things in the BCL, they kind of work reasonably well together. It's always there. You can just use it. Whereas, if you were to write code in C++ and you want to find like an external library to use, like it's horrible. Like every library defines their own integer types, and it type defs it, and it never matches to what you want. You have like these huge if type def blocks. Like the only C libraries that work are like the ones that Sean Barrett writes, like the STB, one single header file include libraries. Those are the only ones that are actually reasonably a pleasure to use. The other one, resources, is the fact that you could go, if you go to a busy street in Amsterdam and you yell, is there a C# programmer here? You are very likely to get someone to say yes.
Actually, that's not a bad question. Is there a C# programmer here? Just before we're like talking to an audience of people who do modeling or.
So, that's kind of nice, if you need to find someone to add to your project. It's a lot easier to find a C# guy than it is to find a custom scripting language person. And the other reason that we like it is that there's great tooling. I'm a very big fan of ReSharper in Visual Studio. We realize that maybe mono-develop today doesn't fit under the label of great tooling, but we're working on fixing that.
There's Unity VS. JB, I can't see you. You must be here somewhere.
Oh, there we are. Oh, no.
There we are.
Oh, there he is. So
Unity
those are the
VS.
two guys that brought you the Unity debugger in Visual Studio. So please buy them a beer at the party tonight if you've enjoyed their services. And actually at Microsoft for making it free. All right, so we have C++ on one side, C# on one side, on the other side, and I want to show an image that kind of describes sort of like the relation of size. Like this is, I've been sort of secretly working on a memory profiler that's not ready yet, but this is an image from it, where basically everything except that red thing in the corner there, that red thing in the corner is the C# memory. And everything else is memory that comes from, that's allocated by C++. So it sort of gives you an idea of how big these two things are compared to each other when it comes to memory consumption. Of course, it's a little bit unfair because, like there's a big shadow map here in the top left. It's not that's, I say it comes from C++, but of course, there is some one that wanted it to exist, and that person, was writing C# code. So even though the red box in the corner is small, it is sort of the command center, that controls all the different subsystems in Unity. So we call C# a managed language. And I'd like to talk a little bit about what that means, like what actually is it that is managed, and if you're not managing it, then who is actually doing this management? So the managed part, it mostly refers to the management of memory, and specifically like the deallocation of memory. Like in C#, you can say, well, allocate a new list of 100 integers, and you could do some stuff with it, and when you're when you think you're ready with it, you just do nothing, you just stop using it, and then you just trust that someone somewhere will at some point probably clean up that memory. That's the part that's managed. And the part, who is actually doing that management is what we call a virtual machine. So IL2CPP, we're actually, we're having semantic arguments about if it is a VM or not. I'm just going to go here and say that it is a VM.
But if you want the full story, then I'm
then
around
talk to Ralph at the party
somewhere.
So I'm just going to, I think IL2CPP is a VM. And it's IL2CPP's job to make sure that the C# code that you write actually gets executed on the processor, on the CPU. And the only thing that the CPU understands is assembly code. So one of the components that a virtual machine, you could call it like a C# runner, if you will, one of the components that it needs to have is a garbage collector. Because you guys aren't cleaning up your garbage in C#, someone needs to do it, and it's the garbage collector in the VM. The other part that a VM needs to do is two parts. One is code, and one is metadata. So let's talk about the code one. As I said, you guys write C#, and out comes a game that works. But a game that works runs on a processor, and the processor only understands assembly. And if you export to an iPhone, that actually requires different assembly code than when you export to your Windows PC. Super annoying for us. So the way IL2CPP works is that you take this C# as input code, and we're going to only look at this update function here. And we're going to see what happens when this C# code, like the path that this C# code travels up until the point that it actually becomes assembly code. So the first step is that we give it to the C# compiler. And the C# compiler, it turns it into this code. So this is what we call IL, intermediate language. It's the, when I say that IL2CPP is responsible for running your C# code, that is true, but what I really, what is more true is that it's actually running IL code. And there's multiple languages that can compile down to this IL format here. So this IL, we convert it to C++, like this. And then this C++, we give it to the C++ compiler of your platform of choice. So in case of iOS, we give it to Xcode, and Xcode actually compiles this C++ into ARM assembly code. So let's take a little bit closer look of how that goes. So let's start off with that first line. So in C#, it just says this.transform, which, if you're a bit familiar with our API, is a property getter. So in the IL section there, you can actually see a call instruction to the get_transform function. And then if you see the generated C++ for that, it makes a call to a C++ function that we generated for you. So
stack-based, register-based.
Really have to say that?
Yeah, that's nice.
Okay. Well, why don't you say it?
Okay, so what you can see on the IL bit is that at IL000, we do load argument 0. So that is normally an argument, but in this case it's this. And then it calls, and then it basically puts that on the stack, and when it arrives at the landing spot, and it's kind of like a VM implementation detail of how it works. It takes the argument and gives it to the function it's been calling. But in the case of C++, what we actually do is transform all that and go back from a stack-based setup to a register-based setup, which is, in this case, we let the C++ compiler deal with it. Sorry, go ahead.
Great. All right, so let's take a look at the second line. We have that rotate call. So rotate 1 to 3 in IL, it turns into these 3 load constant instructions that you see, 1 to 3, and then again a call instruction to the rotate function. And you can see that the C++ we generate for that, it's again a normal C++ invocation, but we actually turn these sort of stack-based constant loading operators back into real C++ argument, how do you call it? Primitives, literals? Literals, I guess you would call it. Actually, the C++ part I have here at the bottom, it's a little bit lying, because what we really do is this. It's not only do we do the transform rotate call, but we also do a null check, because C# guarantees that if you call a function on a null object, that you actually get an exception instead of crashing. It's something that, over time, it's actually very likely that we'll add optimization options to IL2CPP to sort of, that allow you to say, well, I don't really care about that part of C# behavior, as long as you can make it a tiny bit faster for me. I promise I will never invoke a method on a null object.
Actually, we have it today.
We have it today?
Yeah, there's an attribute that you can add to a C# method in one of our experimental branches, where you basically say this method needs to be super fast, so don't do all this kinds of stuff. No array bounce checks, everything that is safe goes away, and you get a little bit more speed, and I expect that to land in the near future, actually.
Cool. Then again, the flip side of that, if you mess it up, like speed and safety, they go hand in hand the opposite ways. All right, so this is what a IL2CPP generated CPP file can actually look like. Not initially a beauty to the eye, a pleasure to consume for a human. Sometimes, though, it's useful to be able to at least understand kind of what the structure of them is to, let's say if we messed up, it could be that you build your project and that the generated C++ code actually doesn't compile because there's a compiler somewhere. You could all, you can go hassle us on Twitter and hope for us to fix it fast, but often what you can also do is actually look at the C++ code, because there's always this comment over there. Whenever we emit CPP code, there's always the comment of like the original C# code that this came from. So if if there's a problem in the generated code for a certain method, you at least know which method it is, and you can sort of mess around. You can try some different things, see if that makes the problem go away. So I mentioned that one of the roles of a VM is to collect garbage, to handle deallocations for you, and the other one is to generate the code that actually runs on the CPU. And you can see that the strategy we chose for IL2CPP is to go through C++. There's a lot to say for that, because there have been man years and man years and man years of energy spent by other people on making these C++ optimizers really fast, making the C++ compilers really fast. So we kind of stand on the shoulder of giants in the way that we can feed the C++ compiler relatively awful C++ code, or let's say non-optimized C++ code, and it will do an amazing job at generating the fastest possible assembly code for your CPU. The downside of that is that the C++ compiler is not necessarily incredibly fast. So, as I'm sure some of you have noticed, if you make a build on iOS, it would be good if you get a cup of coffee. We have another VM too, and it's Mono. Mono is also a VM, so it needs to solve the same problems. It needs to do garbage collection, and it needs to generate code for your processor. But with Mono, they choose a different strategy. Mono uses a just-in-time compiler. So they go from the same IL code, and they generate assembly code right before they execute it. And that's a very different approach. That's not a wrong approach. In fact, it's actually a very nice approach, and one that we need in our editor. Because it's one thing for me making a joke here that if you want to make an iOS build that today you might need a cup of coffee. If that were to be true for the editor, like you guys would be chasing me with pitchforks. So in the editor, we have a requirement that if you guys change your code and you hit play, it needs to work immediately. So there's no nonsense of calling a C++ compiler to take 30 seconds to go to make the fastest possible assembly possible. You just want to see if the code you write was correct. In the editor, you don't care about having the utmost performance that you can get. So this is the fundamental difference between Mono and IL2CPP. Mono does JIT compiling, and it goes straight into the assembly code for the processor, which makes it very hard for us to actually bring it to new platforms. When a new processor comes out with a new instruction set, if you want to make Mono support it, you need to actually do a lot of work in Mono to make it able to generate assembly code for that processor. So one big thing that IL2CPP brings us is portability. At Unity, we used to have platform teams of maybe 3-4 people, and 2 of them, would have almost a full-time job of keeping Mono, first getting Mono running and then keeping it running. But because the C++ code we generate is the same for all platforms, we completely push sort of like the multi-platform problem, or a substantial part of it for us. We are able to push it over the fence to the platform providers who need to ship their C++ compilers. To show you a slide, this is what the assembly code looks like that Mono generates for the same function. It's a bit hard to read, which is actually also a very nice property of IL2CPP, because before we were joking about how the C++ code was maybe not such a pleasure to look at. Neither is this. And actually, for the developers at Unity having to work on this, it's just a breath of fresh air to be able to look at generated C++ code and to see if there's a problem there. It's just much easier than comparing it to runtime generated assembly code for a processor that you might not know the instruction set for. Okay, so that's the big difference between the 2 VMs. Like sometimes it feels like, maybe it feels like we don't like Mono, but that's not true. We think Mono is great. We think it's great for the editor, because there you want fast iteration times. But we think IL2CPP is great for the player, because there you really want the fastest possible code. And, well, especially our development team really likes the portability. Okay, there's a third component of a virtual machine that you need in order to execute C# code, and that is metadata. And that one is all for Ralph.
Yay. Metadata. So there's a couple of pieces of metadata that we actually convert and use in IL2CPP. So here's some of the contention in describing what the VM is. If you look at how Mono does it, even on iOS, when it's Mono ahead of time compilation, which is very similar to what IL2CPP does. It does it before it's on the device. It's before and not at runtime, which is the JIT compiler, is that the information is loaded from the original assemblies, in the sense that they're original. They're stripped from all the actual executing code. They only carry information about all the types. Now, to talk about this, I'm trying to kind of leverage maybe where we're at. Metadata, does that mean something to someone here? Does it mean nothing to you? You know what, let's try does it mean nothing to you? Okay, so that's okay. Then I'm going to dive in a little bit in what that looks like in IL2CPP, instead of explaining too much around it, because we'll get there. What we do today in IL2CPP is that we actually, we're changing this a lot. as part of development, but right now it looks something like this. So we're not listing everything here in this file, it wouldn't be that interesting, but for every type that exists, we write the type information. When I say for every type that exists, that is also not entirely true. There's stuff like generic types, and for those we basically say for a list of T, we don't actually write for every list type which type that was, we just make them at runtime. Now what I'm going to try and use is the simplest piece of metadata, which is here, the name and the namespace of the type. So to give you an idea how you use that, this is something in our test suite, and we just modified that a little bit to illustrate what's going on, but you get the type information for the type datetime test, you get the name out of that, and then we trace the name. And that uses exactly this piece of type information on that type. So the VM part of this, the VM part that we just discussed is something of a thing you can argue about. The actual VM part here is that the internal call that we use to get that information from the type information is something we implement in what we call lib-IL2CPP, which is the VM, the runtime part of it. It contains the GC, but it also contains how to instantiate a generic type. It contains how to use the type information from that. Now to take it a little bit further, the method information. So if we go back to the example that Lucas was showing before, you'll notice something. This is the method body. This is the IL. None of this actually contains information about the actual method. That information sits around it as metadata. So how many arguments this takes is, that's not part of this. The calling convention of putting 3 things on the stack and reading them off and calling something else is basically an implementation detail for the VM on how it wants to deal with that and see if it's correct. And that's all kinds of information that you need to kind of back that. And here's what we do for method information today. As you can see, this is actually everything we have. So let's take that really simple part of this, the name. So how you use that in C# will be something like this. And as you can see now, we're using it twice. If you are a careful observer, the first line is actually doing a lookup for a method by name, the string that we passed to get method. So this goes into the VM goes searching over that type, says give me that method from this type. How it does that again is an implementation detail for the VM. And then we get the name from the method. And to kind of show you, this is not really super secret source code at all. This is how it is in IL2CPP when you call that. So the icall that backs that, the .name property here, this is the code that gets executed. The interesting bit to notice here is that string new, and then how we set that as a reference on the object in IL2CPP object set reference. So we take that name from the metadata, which is if we look back at this, the name is here, it's just a normal C# string. And we create a managed string out of it. It's a different thing. It's like the system string from C# is different than what we use to back it. So we create that new string, and we return that to you, and that's how you use that from that point on. It lives in the VM. If you keep on referencing the string, well, I guess the string is actually a pretty bad example to talk about GC in this case, but somewhat like that. Now to illustrate a little bit more what you can do with metadata, here's the return type of the method. You might want to use this in cases where you're trying to do by reflection and see what you're going to get back, and just to give you a flat idea of what that looks like, and also give you a deeper idea of how far metadata goes. Again, you get the method, so the VM looks up that method by name. And then what we do is we say, okay, give me the name of the return type. So if we go back here, the return type is that void T9, and that's actually a type information again. So where this is a method information and this is the type information, what we're going to get is the type information for system void. And from that, we can get the name again. So metadata is a really important part of IL2CPP, and I mean, without it, stuff can't work. There's ups and downsides to it. Metadata, like we do it, if you look here, in this version of it, sorry, the method pointer type here is the datetime test, datetime to universal. So this actual pointer to the method. What that means is that by referencing that from the method information, the C++ compiler won't be able to strip this anymore. It can't take it out anymore because we're actually taking a function pointer on it. So whether you use it or not, everything that is in there is going to be retained. To reduce the amount of data today, to reduce the amount of data that is in IL2CPP, there's a thing that actually we forgot to put in the slide, Lucas. Stripping. Which is, we actually always run stripping when you compile with IL2CPP. And that is to reduce the amount of metadata that's in there. That's to reduce the amount of methods that are in there. Now, there's a lot of implementation details to IL2CPP. And our colleague, Joshua Peterson, he started a really nice blog post series, which to some extent maybe confused some people because it's truly about the internals of IL2CPP. Really how it works. So when I talked about generics before and how we instantiate generic type, there's an entire in-detail description of how we do that in IL2CPP. It's on our blog, which is where it got confusing to people because a lot of people don't understand why it's on there. It doesn't really describe anything you're touching, but we felt it was really nice to share that information. If you go through the entire series, in the end you'd probably know how to implement IL2CPP.
Yeah, we're hiring.
And we're hiring. That's a very good point. We are hiring.
Yeah, if you make it through the end of the series, we would like
and we would like to have a word with you. Bug. So, before we go too far into that, let's talk a little bit about what IL2CPP within Unity means today. Most importantly, it's used in WebGL. WebGL is a target that only has IL2CPP. There is no mono backend for WebGL. And the reason that IL2CPP exists is partially because of WebGL, because porting mono, like Lucas explained with different architectures, making mono JIT to JavaScript, that seemed like really awkward when we talked about it. We did a hack week to create WebGL. Within that week, we just left scripting completely out of scope. The entire idea of how to do that, we just basically left that off the table and just wanted to port the engine first. But when it became a real thing, then we really had to think about what we needed to do to bring it over. And IL2CPP was kind of a concept that was in conjunction with other things we were thinking about the logical next step. WebGL is really fast. If you look at scripting and look at Asm.js today gets within 1.2x of native speed, if you don't consider threading and all these types of things. And in some cases, with IL2CPP and with all those optimizations that became run in the C++ compiler, which in the case of WebGL is Clang, it can optimize so good that it can be faster than Mono on standalone. Now, some of that comparison is unfair because it's JIT versus AOT, so it can spend a lot more time compiling and doesn't need to have the method next up there, but it can be faster in a web browser than it can be in pure native code on a standalone. That's pretty insane. The other thing is iOS. I'm sure you've all seen, if you were publishing for our iOS, I'm sure you've all seen the Apple announcement beginning of last year, or end of last year, in somewhere in November, where they announced that you need to have 64-bit for your apps. And you need to have that for any new app by February, and for any update by June. So here are we with our version of Mono that nicely targets ARM32, but doesn't target ARM64. And here's us with IL2CPP that we were building so that we could easily target new platforms with architectures that we didn't support yet, and not spend a year on trying to make that architecture work correctly. So instead of taking Mono, or actually trying to build a Mono backend, which would have taken us a lot longer than doing this, we took IL2CPP and started working on that. Now, admittedly, we've had a rough patch. We've also had many patch releases to go through that rough patch. No, nobody.
How many people here shipped a game on IL2CPP?
Yay, yeah. Well, and talking about, so we feel that even after this period of us doing a whole lot of patch releases I think we were close to 400 patch releases just for IL2CPP, just to make sure everything was okay for everyone. I think this was a giant milestone for us, which is Hearthstone, which if you, we get to look at the code from the assembly perspective. There's a whole lot of it. 64-bit on mobile, and the nice thing here is it's so much snappier, it's ridiculous. And while 64-bit on iOS on alone, you can already take a native app and compile it and compare 32-bit against 64-bit on ARM v7 and ARM64 and see that there's a performance difference. The actual scripting speed difference on Hearthstone, I believe, is probably some of the explanation why it's so much snappier. I can't say it is because it's not something I deeply profiled, but we can see across the board that IL2CPP is basically a performance booster for apps. More so with very math-intensive stuff. So if you're drawing a Mandelbrot, which is something we had a lot of times in presentations about IL2CPP, IL2CPP can be about 8 to 9 times faster than Mono AOT on iOS was. It allows you to do things in C# scripting that you wouldn't consider before because of speed reasons. The truth about that is, of course, if your game is very heavy on just rendering, right? You have really complex 3D models with large textures and all the memory is being, the memory bandwidth is being pushed to the limit, and that's why you're slow, of course, then your scripting performance is not going to make the difference. But one of the things that you will see is that if you have very computationally heavy scripts, IL2CPP will generally outperform what we had on Mono before. And with that, we're not stopping right there, we're actually pushing further. And that is some of our future. So one of the things I was very happy to see Lucas announce this morning is something we've been working on for a while, which is our public roadmap. So all the things that I'm going to talk about right now are things on our public roadmap, but I'll try and illustrate them a little bit better by explaining what we mean when we put those on the roadmap itself. And I'm starting off with stuff that you will see in the very near term in a Unity downloadable. And one of the ongoing tasks, and this is hard to say it will be this version or that version, because we don't really stop on working on it, is distribution size. So to go back to that idea of metadata, the metadata that I showed you that had the name and the namespace for the type, that all goes into C++ files. So that all gets compiled into the binary of your app, and it's constant data, and it goes in a specific segment of your app, but it's part of the binary. And when the C++ compiler gets that, and you tell it, okay, make a 32-bit app out of it takes all the metadata and pushes it in. Now on iOS, you're today shipping a 32-bit version and a 64-bit version if you publish that way. What that means is that if we push all that metadata to the C++ compiler, first the 32-bit version gets all the metadata, and then the 64-bit version gets all the metadata. So both versions include data that is shared between both versions. So that's not that handy. What we're working on, and one of the things why I said earlier that this metadata is changing all the time, is because what we're restructuring right now is how the metadata is actually subdivided in runtime data and constant data, and also subdivided in a way that looking it up from the runtime when we do something like this, is in such a way that we basically get the data from a table and then be able to, let's say, externalize the data. So one of the things that we're doing right now is making sure that what IL2CPP outputs is not just C++ files, or actually no C++ files for the metadata, but a binary blob that we load up into IL2CPP, and then that can be shared between 32-bit and 64-bit, which arguably can save a lot of data if you look at the over-the-air size of your application. Now, that also addresses another thing, and that is the coffee that Lucas had a whole lot of over a period of time, and that's build time. We really know that that's an issue in terms of iteration times. Of course, what we believe in is that if you're working on your game, then most of that work and most of the iterations should be happening in the editor for you. But we also understand that you're doing iterations on the device to test different versions or to test different things on the actual device. So build time is something, yes, we understand that, and we want to actually optimize that. It's something that we're working on stepwise. The actual work we're doing on the distribution side, so externalizing that metadata, means that the amount of C++ code and the amount of header files that we throw at Xcode is going to be significantly reduced. But of course, the amount of code, the actual things that are unstrippable, because we reference it from metadata, that will always be there. I think that we can honestly say that a 20% reduction based on just the metadata is reasonable. Then there's another thing, memory usage. The Mono AOT VM and the IL2CPP VM don't behave exactly the same. They are not supposed to. They have slightly different GCs. We are slightly treating how we use memory differently. And one of the things that we do very differently is if we have this generic type that uses metadata, we instantiate it, but as soon as you use the type information, we also instantiate all the method information. That might be fixed this week or last week, but it's one of the things that the lazy initialization of data is something that we tried, but we were not that good at it. So if you would get the type information of everything in your game because you were using a certain type of serializer that would expect that through reflection, you might be using more memory than you were on Mono. And to our realization, and this was actually a very honest realization we had while working on this and while working with people trying to ship their titles, is that a lot of people tweak their game to be very exactly within the confines of the lowest common denominator on iOS. So an iPhone 4, for example, will be limited at around 200 something megs. and they had tweaked their game exactly to fit in there, and now we come along with IL2CPP, and it uses 3 megs more out of memory. That's something
you guys are completely on the edge.
Yes.
Like if we make a change that allocates like a kilobyte, suddenly we get phone calls from half of you. That kilobyte, it just pushed us off the edge. We didn't realize that up front. We thought it would be a more natural distribution. Some guys use a lot of memory, other guys not so much. But it turns out that everyone, it feels to us, everyone is just exactly at the limit.
Yes.
Exactly at the limit.
Within the kilobytes, that's the scary part.
So whenever we need to do something that allocates a bit of extra memory, we've actually been thinking about waiting for that to see when we can pair it with an optimization that saves a few, so that we don't, so that at least they come in the same version, so that we don't get all these people dropping off the cliff.
Just by a centimeter. So the other thing is really important to us, and that is on the public roadmap. In 5.2, we're shipping IL2CPP as a beta on Xbox One and PlayStation 4. When I say beta, that means that Mono will still be the default backend, but the quality of IL2CPP, and this is one of the so nice things about how we're developing IL2CPP, because there's no architecture or machine-specific implementation details in the VM bit, the thing that does the code generation. We expect this to be as stable on those platforms as it is on iOS today. The only thing that is different is the VM bit, so if your sockets implementation, if somebody at Unity made a bug in the sockets implementation, then that might show up. But we would really encourage you to use it, because even the PlayStation team on their initial benchmarking on performance are saying that they're seeing huge performance increases on it. Now, another thing where IL2CPP shines, and something that's on our roadmap, is that for Windows Store apps, I never know what to call it anymore. Is it
Windows? I think it's Windows Store apps. Windows Store apps.
Let's just stick to that before we say it wrong. These modern Windows UI apps that you use, they have a different backend today. We're using Microsoft scripting backend. We're using the actual .NET CLR that Microsoft has on that platform, and we have like an abstraction in Unity for all the different scripting backends. And that's a different runtime, and sometimes it's actually one of the craziest things we've seen is that how much people can rely on bugs in a VM. There's people relying on stuff that are bugs in Mono, and we can't fix them until we are basically rid of Mono, because otherwise we behave differently. The thing that we see in .NET is actually, it's a very good, we use this as the benchmark of what the correct behavior is. But because it's different, people's games will not run on one platform or the other. And this is one of the things we think IL2CPP will shine in. It has a couple of caveats. I won't go too deeply into that. But it's something that we're planning to ship as a beta in 5.3. Then a platform very similar to WebGL, in the fact that it doesn't have the Mono backend, but only has IL2CPP, is the 3DS. No dates on that just yet, but it is in full-on development. And then as we go past platforms, we're working on a debugger on IL2CPP. So right now you cannot attach Unity VS or Mono Develop to IL2CPP runtimes. There's just no implementation. You need to actually implement, when somebody sets a breakpoint, we need to have to set that in the code, and have these sequence points that you can actually break at, and there's a whole lot of details. We have been working on that for quite some time, then decided that priorities should be differently, but we're continuing now. Now we go into the far future, which is the research phase. So Windows, Mac, and Linux. I guess you had a question about that. We talked about that.
Well, explain the problems that we're having first.
Okay, so Windows, Mac, and Linux standalones using IL2CPP. So the obvious benefit is performance, and this is very interesting to a lot of people. And the problem space that we're running in, we actually have these. We use these for debugging. We use these for IL2CPP debugging. It's just really fast for us to do it on the desktop and easy to debug. But if we want to build a Windows build, we're on a Windows machine. If we want to build a Mac build, we're on a Mac machine. And on Linux, actually, we don't have that today, because we need the editor and we need the actual tool chain for the compilation to be on the machine. So we don't have cross-compilation.
Right. So, does anyone here ever make a Windows build on a Mac?
1 person, 2 persons, 3 persons?
Okay. Oh shit!
Yeah, this is a lot. So this is good information for us.
And people making the other way. What did people making Mac builds on Windows?
Yeah. Okay. So cross-compilation is kind of important. So here's what we're.
Well, so who would be sad if that would no longer work? It's a little bit. Oh.
So what? So,
but just for why? Why? Like, can we get a mic in the audience just for like? Do we have a mic?
One reason is continuous integration, for example, to save some costs. I mean, at the moment we are using one server to build all versions in a pipeline. When you will separate it, I'm here, hello.
Okay. Thank you.
So when it's not possible anymore, we need a Mac server, a Windows server, and perhaps a Linux server separately, and it's not buildable on one server. So costs, build pipeline. It's a big reason.
Any other reasons? Really, everyone here everyone does it because of continuous integration?
Yeah. Hi. Yeah, we are doing work for hire, and all the team is working on PC, and all the clients we have are working on Macs, and so we make a lot of Mac build from PC. We can't have a Mac for everyone in the team, so we send Mac builds to clients.
So that research bit there, you're now actively part of the research bit.
Yeah.
The problem we're facing is the cross-compilation pipeline on the different machines. There's ways that we could maybe do it. We don't really know. We don't want, well, I guess now we know we have to invest a little bit more brain power into how to solve it. One of the things that we think we can do earlier rather than later is we have Unity Cloud Build. We could do this for you and you would get a build from the cloud instead of being able to build it locally. But I guess the actual problem of having your own integration or continuous integration builds defeats that purpose. So it's, yeah.
Oh, I was really hoping for like no show of hands because I've wanted to ship this from the beginning, but Ralph keeps saying, no, this cross-compilation, it's really a problem. And I was saying, no, no one cares about that.
So I guess I was right. You could say that on stage. It's hard, I know. So who's excited about something like this? A .NET profile upgrade.
Oh.
So again, this is in the research phase. It's something in the longer term. Why is that? And the primary reason is because we need IL2CPP on all these platforms before. We need to actually roll out IL2CPP on all platforms except for the standalones. And get it up and running there before we can start thinking and working on this. Right now, IL2CPP reaches parity with our current version of Mono. That means on the entire surface of the VM, parity is aimed at our current Mono, which is a 2.0 runtime, which supports .NET Profile 3.5 Max. 4.0-ish in some cases, it's a bit awkward. No C#6 if you really want to use the entire feature set and not figure out if it can work or not. So this is something that comes after that. This comes after we have IL2CPP up and running on all the platforms. Then we have IL2CPP up and running as a 4.0 runtime, and then we'll bring this over. So this is very long term. Then another thing which is really important to us is bringing it to a new GC. We've always architected IL2CPP to have a pluggable GC, but there is some actual changes in the GC. So right now we're using a newer version of BOEM than our current version of Mono is using. But if we would go through truly new GC territory, it would be something like a moving garbage collector or a generational garbage collector. And that poses more problems than just putting the GC in. Unity expects things about a GC that we would need to change. So there's that. But we do know that this is important, so this is actually one of the focus points. Lucas has already been playing around with the Microsoft GC. Is that correct? To the point?
Yes, I've been playing around with it. This is correct. Maybe we should skip the SIMD part so we can take some questions.
Yeah, let's take some questions, and then we can see how it ends up.
Yeah. Actually, one thing I wanted to mention is, like the IL2CPP team, we ship bug fix releases on 5.0 and 4.6 every week. So we try to be really aggressive when a bug report comes in. If it's at all possible for us to fix them, and honestly, like most of the bug reports we get are reasonably easy for us to fix. Like we have a pipeline to fix them that I've not seen at our company before. Like from when we see the bug and think like, hey, I know what this is, to when we can have the patch release in your hands is 1 or 2 weeks. So if you're running into trouble, we'll be honest. Like it's a relatively young product. The people who were there very early on iOS can surely attest to that. That they'll surely have run into some trouble. But if you find something, if you let us know, we'll make sure to have a fix in your hands as soon as we can. And in many cases, this is in a 2-week kind of period.
I think our badge of pride within IL2CPP is a 2-day turnaround on a bug.
Yes.
That was
All right, are there any questions? Yeah, can we get the 2 mics running, please?
maybe the house lights. Yeah.
Yeah, raise them, Andy. Oh, here we are.
Hello, thanks for your presentation. You mentioned that you are working on some improvements for MonoDevelop. Could you provide a little bit more details on what exactly you're working on?
Yes, so the first step we'll do is we'll upgrade to the latest MonoDevelop, but do it in a way that we do it against a completely clean checkout of the upstream MonoDevelop. So all our stuff will be in a single add-in. So that will make it much easier for us to keep up with upstream MonoDevelop changes, because today we have a lot of sort of custom changes that we had to do. We're cleaning all that stuff up, and that should ship in 5.3.
5.3 December.
5.3?
December 8. But it's not the latest.
Many MonoDevelop complaints are actually about the debugger. And when we investigate these issues, it often turns out that the problem is actually not in MonoDevelop, but it's in Unity. So I think in Unity 5.2 already we'll have a lot of debugger fixes. And then I'm so happy you asked the question. Like, my pet peeve project is that what I want to do is I want to take MonoDevelop what it is today, but modify it to only do one thing well, and that is edit C# scripts for Unity. So basically rip everything out. Like right now it can do a lot of things. But I want to make it like the most minimal thing that's useful to work with Unity. And do we have time?
We have enough time.
Yeah, it's because it's my favorite topic. So for instance, one thing that we've been working on is removing this nonsense of Unity creating a project file, and then MonoDevelop opening the project file, and then you change a file in MonoDevelop, and then Unity overwrites it again, and they have to reload the solution, and it closes down, and it opens up again. The new setup that we're working on, it will make Unity run a REST server, and then MonoDevelop or any other script editor could talk to Unity over the REST service to do things like, would you please compile? Or would you please rename this script without breaking all my references? And that comes with a lot of advantages, like the build errors actually being the same as in Unity, and also that you don't need to do this solution unloading all the time. I was actually hoping to ship it in 5.3, but it looked like we didn't make it, so we decided to split the work up, to first do the MonoDevelop upgrade, and after that do sort of like, you know, Lucas's fancy REST service integration minimal thing.
Lukas.
Yes, and I'm saying it like I do it, but the guy that's actually doing the work is also called Lucas, so it's easy to take the credit.
Who's working on that, Lucas?
Yeah. Any
More
other
questions?
questions? Thanks. Can we get the next mic to the next question?
Yeah, do you check out the C++ code you generate with any tools, so you can check out the static analyzing or stuff like that?
I'm sorry, can you ask the question again?
Yeah, do you check out the code with any tools that you generate, so you can check out for static analyzing errors or stuff like that? Because right now we are getting like 400 Xcode warnings in the code.
Right, so the first thing we should do, so the first static analyzer of the code is the compiler. And it is already throwing a bunch of warnings at us. And these are problems in our code generation that we need to fix. Once we have fixed all the warnings on all the platforms, then a likely next step is to, you know, throw it into, what is it, like PVS Studio or like the Coverity scanner, and see what kind of, you know, see if that allows us to find problems in the code generation. It's definitely something we want to do. But
actually, if we have warnings on iOS and Xcode today, that's basically a bug we didn't catch before shipping, because it's something we've done in 3 passes. It's just that warning as errors on iOS. There's another warning which we couldn't fix, and that's why we didn't switch it on initially, and then we're shipping something as a bug. Most warnings that you'll see will not actually have impact on the execution of your program.
But I mean, it's totally a good idea.
Yes.
Because, you know, that it's not the case that the last bug has been fixed, and any tool that we can use to find it would be good. And so I would actually love to do that experiment. But first, we'll fix the compiler warnings, because those we already know about.
Thanks.
Next question. Was there somebody with a mic already, or? Oh.
Can we get the next mic to the next person already, so we don't have to wait?
Somebody here?
Okay.
Great.
So, have you thought about that you compile the code to native.NET, Microsoft.NET code, so it can run in the native Microsoft.NET in the editor, so you can use the, for example, Visual Studio compiler with the native.NET compiler. Obviously, this will upset a couple of Mac users. But it seems to me like a very interesting way of getting a debugger, a very high quality debugger from Visual Studio, for example, to work with the Unity editor together and still have the IL2CPP as a backend for the runtime, super fast and so on. Well, but don't have to bother with the debugger or a soft debugger for Mono or something. If you can compile to the .NET in Microsoft Windows, that is shipped with Windows.
It would probably, so in our test suite. So we build actually, while building IL2CPP, we built this giant test suite. Everything we do is test first. So every little piece of code that we write is code that is also tested. And one of the things that we found is that we build these tests that are comparison tests to see if IL2CPP is doing the right thing. And we run them against Mono, and we can run them against Microsoft.NET. We now have a separate test suite that says these are special behaviors because Mono and .NET don't do the same thing. Now that might be, sometimes it's actually not very well defined behavior, and you could argue that either side of the fence is right. But most projects and most of the bugs that we had to fix that were kind of awkward to fix were bugs of IL2CPP behaving different. Maybe it was an implementation detail, maybe it was us following Microsoft.NET implementation, and then we're getting a bug. So doing something like that, and especially in scope of, let's say, switching .NET profile, most of the time we'll want to bulk up all of the breaking changes. So before we even start thinking like something like that, that will be the first thing to do. Of course, it's an avenue we can take. It's just a very expensive avenue to take to just research. It's not a Hack Week project. It's a Hack Week year.
I mean, one thing we could do, which I think is what you mean, like, we could rip out Mono out of the editor and put in core CLR, like
yes,
.NET VM.
That's exactly what I thought.
So that you can then, because core CLR is the VM that Visual Studio is able to natively debug without Unity VM.
Maybe make it a command line so nobody actually know about it except me. I don't care.
Right. So it's not, I mean, it's it's technically possible, but it's not very likely for us to do work on that until core CLR really works well on the Mac. Because the few upset Mac users, they have my Twitter handle right here, and they don't have yours. So we'll be the guys that get into trouble. But seriously, the question makes a lot of sense. But we feel we have so much high pressure points in the scripting area in Unity, like GC. Script editing,
.NET profile,
like these things are to us so important that basically anything else kind of sort of like blurs in the distance, and we'll kind of look at that when we get through these three big ass things.
Yeah, well, you're still working on improving the debugger side of
yes, absolutely.
Unity.
I mean,
this would be wasted then if you have a better alternative.
But I mean, the Mono backend that we have right now, I mean, that's the first priority to get that experience right. I mean, that's where we invest right now, and we're actually heavily investing in making that a much better experience already. What you're proposing is more of a longer-term resource project, and it's just a different kind of quick versus long-term win. And we don't even know if it's win today. We can't even say if it is.
I think though, I think in 5 years, it is very likely for our editor to run on core CLR.
I mean, who of you thought that a couple of years ago you would have now IL2CPP? I mean, as you first announced it, I mean, to me it sounds like, okay, these guys are gone crazy. And now it works.
We have.
We have gone
both
crazy.
True.
Yeah. More.
Hi. Are there any plans to decouple IL2CPP releases from the actual mainline patch releases? The reason I'm asking that is that a couple of times now we've had some blocker bugs that were fixed in IL2CPP, and the patch releases that fixed them had regressions in completely unrelated subsystems. Well, most notably the UI system, where thankfully you can just put the old UI system in, etc., etc. But this shouldn't really happen.
No, and that's true. Actually, when we have a patch release that regresses, that's of course horrible. That's something we don't want. For that, what Thomas said today on stage, we're really focusing on getting these patch releases out at a rapid rate, but also making sure that you can rely on them. One thing that you should take into account is that a patch release you should only take when it fixes the exact bug that you need fixed. And otherwise, you need to get one of the dot releases, which might actually address any of the regressions that you have. Okay.
Actually, the hack that you do for UI, that you move back the old one, you can, like, if you don't tell anyone, you can do the same one for IL2CPP. That you take the new one.
Oh, please don't. Oh, no.
Sorry.
Because then we're getting bug reports against
Probably
versions
won't
that
work. Probably won't work. But should you try it?
You should not do that. No guarantees, no warrant. Well,
really? Are you really going to kick us out?
I have to, sorry.
You have to kick us out? Okay, so me and Ralph will be around for a while.
There's a speaker area, but I don't know where it is.
Dude, it's the only sunny day in the year.
So okay, we'll be outside. We're going to enjoy that together with you.
We'll be outside here. If you have any more questions, please come see us. Thanks for joining us in Amsterdam this year.